In this lesson, we are going to look at another way we can write an equation, and it's called general form. So the slope-intercept form, which is what we looked at in the previous two lessons, is one of the most common ways to write the equation of a line. Suppose you place a transparent grid on the Canadian flag. Most, but not all, of the line segments in the flag could be expressed as equations in slope-intercept form. Can you think of a type of line that cannot be expressed in the form y equals mx plus b? How about a vertical line? Vertical lines have undefined slope, so we wouldn't be able to write it in this form. So in this lesson today, we're going to explore a general way of writing the equation of a line. Now, the general form of an equation of a linear relation is ax plus by plus c equals 0, where a is a whole number and b and c are integers. So the rules are, a must be positive. There cannot be any fractions or decimals in the final form, and the equation must equal 0. So we want to manipulate these equations. So we want them to be equal to 0. So we need to move the 5x and the negative 7 to the left-hand side. To do that, we use inverse operations. So it doesn't matter which one we start with, but let's pick add 7. So we will have y plus 7 equals 5x. We want to make it equal 0. So now we're going to subtract 5x. And we want to write it in the form x, then y, then the constant. So now we run through our three rules. Is our equation equal to 0? Yes. Are there any fractions or decimals? No. So 2 out of 3 we're good on. Is a positive? And a is the number that is with the x. The answer here is no. So we need to make that negative 5 into a positive 5. We can think about it as either multiplying every term by negative 1 or dividing every term by negative 1. Either way, you are ultimately going to change each sign. And now we have our equation in general form. So if we look at the second example, we have one extra little catch to it, and that is that there are fractions. Fractions are okay in slope-intercept form. Fractions are not okay in general form. We could manipulate this with that fraction, or, because we know we need to get rid of them, we could eliminate the fraction right off the bat. And how would we do that? Well, we are going to multiply every term by the value of the denominator. The denominator is 3. So we multiply every term by 3. We end up with 3y equals. Now 3 times 2/3, the 3's end up canceling out. This is the same as saying 3 over 1 times 2/3. 3 goes into itself once in both cases, so you would just be left with 2 over 1, which is just 2, and it was a negative, plus 12. And now we are back to the point that we were in example A. We need to move everything to one side so our equation is equal to 0. So we can start by subtracting 12. And again, it doesn't matter which order you do it, and you could choose to do both in one step. Now we are going to add the 2x, write in the form x, then y, then the constant, and go through the three things. Are we equal to 0? Yes. Do we have any fractions or decimals? No. Is a positive? Yes. We're good. It's in general form. This third example starts out in a different form, but we are still able to manipulate this to general form. What we need to do first is we need to get rid of those brackets. And to get rid of the bracket, we distribute the 4 through the bracket. So we end up with y plus 3 equals negative 4x plus 20. And now we just manipulate it so it's equal to 0. So we start by subtracting 20. And we can combine the 3 and the 20 together here. So we have y minus 17 equals negative 4x. We add the 4x to both sides. So we get 4x plus y minus 17 equals 0. Run through your check. Are we equal to 0? Yes. Do we have any fractions or decimals? No. Is A positive? Yes, that is in general form. Let's look at this last example here. Again, we have a fraction. So let's deal with that fraction right off the bat and get rid of it. The catch in this one is that when we multiply by every term, we need to understand that the entire right-hand side counts as one term because that 3/5 is being multiplied to the bracket. Those are considered together, and eventually you will distribute the term out in front, so we do not multiply 5 into that bracket. So we multiply 5 to the y, to the 1, and then to the entire right side all at once. So we end up with 5y minus 5 equals. 5's will cancel out. It's just the same as 5 over 1 times 3/5. 5's go into themselves once, and you're left with just 3. Now we are at the point that we were in C. We distribute the 3 through the bracket. So we have 5y minus 5 equals 3x plus 6. And now we continue. We can subtract the 6. And then we can subtract the 3x. So we have minus 3x plus 5y minus 11 equals 0. So let's do our check. Are we equal to 0? Yes. Do we have any fractions or decimals? No. Is our A positive? No. We need to make A positive. So just like we did in the very first example, either think about it in the fact that you're going to divide every term by -1, or you're going to multiply every term by -1. Ultimately, you are simply changing every sign. So 3x minus 5y plus 11 equals 0. And now you have written it in general form.